Look at the physical scale of the Great Pyramid of Giza. 4,500 years ago, human hands moved 2.3 million individual blocks of limestone, each weighing up to 2.5 tons, into a single structure without the use of a single machine. For centuries, the standard historical assumption has been one of additive architecture, that the pyramid was stacked layer by layer from the ground up. To achieve this, the primary theory suggests the Egyptians utilized an external ramp system to hoist the stone. But the engineering math reveals a problem. To drag a 2.5-ton block of a workable, low-friction incline, a ramp would need to be roughly 1.5 kilometers long. It would require as much material as the pyramid itself. Despite decades of research on the Giza Plateau, no archaeological evidence of a structure that large has ever been discovered. The logistical requirements of an external ramp contradict the physical reality of the site, leaving a gap between theory and engineering. When the math on the exterior failed, some researchers proposed an alternative, a winding internal ramp system built inside the pyramid as it grew. That theory was tested in 2015 using muon particle scans, which essentially X-ray stone densities from space to map the interior. This scan data reveals massive, previously unknown empty spaces, but it shows no evidence of a structural winding internal ramp. Even if the ramp problem is set aside, every bottom-up construction theory eventually encounters a fatal geometric flaw, the apex. Forming a point requires extreme precision. If the initial measurements at the base are off by even a fraction of a millimeter, that error compounds as the stone rises. By the time the four walls meet 146 meters in the air, the lines would miss each other. As the building nears completion, the workspace shrinks to a tiny point. Hoisting and positioning multi-ton blocks at this height on a microscopic platform is a physical impossibility. If every additive theory results in missing evidence or geometric failure, it suggests the builders may have used a different process entirely. To see how ancient engineers solved this, we look to the desert of Jordan and the 2,000-year-old city of Petra. These towering facades were not built from the ground up. Instead, they were carved top-down, directly into the existing cliff face. This subtractive method uses gravity as a tool. By starting at the top, builders allowed debris to fall away naturally rather than fighting to lift it. Ancient builders already possessed a technical mastery over subtractive engineering, a logic that fits the physical evidence found at Giza. After 10 years of mapping the Giza Plateau into a three-dimensional stone-by-stone model, researcher Yan Choi proposed a new framework, the Unbuilt Theory. Choi's model shows the builders did not start on flat sand. They utilized existing natural limestone hills on the plateau as the core of the structure. Next, they built an oversized flat mound over the hill, much wider than the final pyramid. This sheer width hid a gentle internal slope, making it easy to drag blocks upward. Finally, builders carved the pyramid downward from this platform, stripping away excess rock. This approach eliminates the apex dilemma. By starting at the top on a wide, stable surface, measuring the geometry of the peak is simple. Gravity then handles the disposal of waste stone as workers move toward the base. Treating the pyramid as a sculpture rather than a masonry wall makes these engineering feats logical and practical. If the builders carved a giant mound down to a pyramid, it raises a question: where did the 2 million tons of waste rock go? Choi's data reveals the excess stone was recycled. It provided the building material for the neighboring Khafre and Menkaure pyramids and the surrounding temples. The total mathematical weight of the entire Giza complex matches the tonnage required by Choi's initial mound model. Physical evidence for this method appears in recent drone mapping of the Khafre pyramid walls, which identified specialized locking stones. These stones were found precisely in the middle of the walls. This proves construction teams worked inward from all four corners at once, meeting in the middle to lock the sections together. An exterior ramp would have blocked these corners, making a multi-team workflow impossible. Only a wide, open carving platform allows for this type of simultaneous construction. The unbuilt theory is still being debated, but it provides a logical path through the site's engineering contradictions. The Great Pyramid stands as a result of stone removal, shaped by the same top-down precision seen through